Hello children, welcome back to our physics class. I hope you're all doing well and ready to explore something new today. Well, in today's class, let us discuss in detail how the rotation of the mirror affects the incident ray as well as reflected ray. Yes, apart from that, let us also learn what exactly is a lateral inversion as well as how the position of the image affects, that means how the displacement and velocity of the image changes with respect to the position of the object. So, here first of all let us discuss in detail regarding the rotational effect of a mirror. So, this first concept is all about your rotation of mirror. For this, let us consider a mirror as shown in figure. Let this be a mirror. Let us name this mirror as M dash. Let us name this mirror as M dash. Let N be the normal drawn onto this mirror such that the normal meets the mirror M dash at some point, say B. Some point, say B. Okay. So, clearly M dash is the given mirror and NB is the normal drawn to this mirror. Suppose if a light ray is incident on this mirror, then this will be your incident ray and the same light ray is reflected back into the same medium. The light ray is reflected back into the same medium such that the angle of incidence I is equals to angle of reflection R. This happens to be the incident ray and this happens to be a reflected ray. So, this is the basic concept which we have studied till far. But what if the same mirror is rotated? Let us suppose that the mirror M dash is rotated to some new angle, some new position, say M1 dash. So, let us indicate the same. Let us suppose that this M1 dash be the new position of the mirror. Earlier position was M dash. Now, as the mirror is rotated by making an angle theta, then M1 dash indicates the new position of the mirror, and let us suppose that the mirror is rotated at a point B, through a fixed point B. When the mirror is rotated through this point B, making an angle theta, very clearly we know that the normal also shifts by same angle. That is, if this indicates the previous normal perpendicular to the original position, then the new normal position will be perpendicular to this, something like this. That means, if the mirror is rotated by an angle theta, then we observe that the normal also, no doubt, normal also shifts by an angle theta. This was the original position of the mirror. So, normal perpendicular. New position of the mirror, now normal perpendicular. So, angle between the original position and new position theta, angle between the new normal and original normal is also theta. Okay. So, N is the initial normal and N dash is the new normal, position of the new normal. So, clearly what our observation is that in this, when the mirror is being rotated by an angle theta, normal also turns by an angle theta. But the incident ray, there is no change in the incident ray. Incident ray remains constant. So, whenever this normal shifts to new position, with respect to this normal, the incident ray will again moves. This is the angle between the incident ray. Here is your angle between the incident ray and the new normal. Similarly, the incident ray shifts based on this normal. The incident ray takes a new position. It is something like this. I hope this is clear. So, with respect to this previous normal, this is a reflected ray. But with respect to the new normal, this indicates a reflected ray, but the incident ray being same or being fixed. So, the original position between this part is I and this part is theta. So, the complete angle will be I plus theta. Angle between A, B, N dash is found to be I plus theta. Similarly, the angle between the reflected ray and the normal drawn to that is DB N dash must also be equals to I plus theta. Okay. So, to avoid confusion, I am just removing these two lines, children. Okay. So, for the new position of the mirror, this also I will remove. For the new position of the mirror, this is your normal. With respect to the normal, the angle of incidence is until this value it was I, and again the rotated part is theta. So, total portion is I plus theta. Similarly, between D, B, N dash also we found it as I plus theta. Okay. So, based on the conditions, let us discuss in detail now. Okay. So, first one, let us try to find out how much the reflected ray is being rotated. Before that, first of all, let us focus on the angle ABD. So, what is the value of angle ABD, children? Angle ABD can be written as angle ABN dash plus angle DBN dash. Clear? Angle ABD can be written as ABN dash plus DBN dash. That's it. That means angle ABD can be equals to ABN dash is I plus theta, and again DBN dash is also I plus theta. Okay, or angle ABD can be written as I plus I is 2I, theta plus theta is 2 theta. So, based on this, so what is the total angle, children? Angle ABD is equals to I plus theta, that is equals to 2I plus 2 theta. Clear? Now, let us try to understand how much the reflected ray is being deviated. In order to find out how much the reflected ray is being deviated, we need to find out this particular complete angle. This is the total. This was the initial reflected ray and this is the position of the new reflected ray. So, we want to find out this angle, how much the reflected ray is being deviated. In order to find out this particular value, that means RB, R dash, let us go through this carefully. First of all, observe this initial value. Okay. So, instead of writing it as R or R dash, let this be ABC and this be ABD. So, children, we can write the value of angle ABD. Angle ABD can be written as angle ABC. This total portion can be written as this part ABC plus this part, that is DBC or CBD. So, angle ABD can be written as angle ABC plus angle DBC. Clear? In order to find out the angle DBC, so we have to find out angle ABD minus angle ABC will give you the value of DBC. This is what we need to find out. But what is the value of ABD, children? The value of ABD is just now found as 2I plus 2 theta. And what was the angle ABC? In order to find out the value of ABC, just avoid these two lines. Okay. So, ABC means if this is your incident light ray, this is your incident light ray and this is your reflected light ray. The angle of incidence is given as I with respect to the first normal and the angle of reflection is equals to R. But according to the law of reflection, I is equals to R. So, the angle from figure, it's very clearly we can say that angle ABC is equals to angle I plus angle R, but as angle I is equals to angle R, we can replace ABC with I plus even R is replaced with I, or angle ABC is equals to I plus I is 2I. So, ABC can be replaced with I plus I, that is 2I. Okay. So, first of all, what is ABD? ABD must be written as 2I plus 2 theta minus ABC is replaced with 2I is the value of DBC. What is DBC? The DBC indicates the angle through which the reflected ray is deviated. Hence, 2I and 2I gets cancelled. So, you are left with 2 theta. Therefore, the final value of DBC is found to be 2 theta. So, from this we can conclude that whenever a mirror is rotated by an angle theta, we observe that the normal is also deviated by an angle theta, whereas thus reflected ray is deviated by an angle 2 theta. Reflected ray is deviated by an angle 2 theta. So, this is our conclusion part. So, let us recall back all the things. Whenever a mirror is rotated by an angle theta, normal is rotated by angle theta, being the incident ray being at the fixed position, but the reflected ray deviates by an angle 2 theta. So, let me rewrite all the observations here. So, first one. So, whenever a mirror is rotated, arrow mark indicates rotated by an angle theta, we observed that the normal also rotates by an angle theta, whereas the incident ray being at the fixed positions, that is no change. Earlier also the incident ray remains at the same position before turning the mirror. After turning the mirror also incident ray keeps at the fixed position, whereas the reflected ray deviates. Reflected ray deviates or rotates by an angle 2 theta. So, these are the things you need to remember. Okay. So, based on this, we have many applications that we will be solving for different numericals. Got it, children? So, this is all about the effect of rotation of mirror. So, now let us discuss in detail regarding what exactly is a lateral inversion.